expression here that says we need to prove that tan alpha plus beta divided by cot alpha minus beta is simply equal to tan squared alpha minus tan squared beta divided by 1 minus tan squared alpha tan squared beta. So now let's prove that the left hand side is equal to the right hand side. So we have tan alpha plus beta here divided by cot alpha minus beta here. This here is the same as, we not say that tan is made of the quotient of, or rather when you divide the same function with the cosine function here. So meaning that here we can simply have sine alpha plus beta like this, cos alpha plus beta, then we divide it with the cotangent function here, but then the cotangent function is simply the reciprocal of a tangent function here. So meaning that here we're going to have cos alpha minus beta divided by sine alpha minus beta like this here. So if we change this symbol that we have here into a multiplication symbol, we're simply going to have sine alpha plus beta here divided by cos alpha minus beta like this, multiplied by, so the denominator here becomes the numerator and the numerator becomes the denominator. So meaning that here we're going to have sine alpha minus beta divided by cos alpha minus beta like this. So now we're going to use these identities here. So we know that sine alpha plus beta simply equal to sine alpha cos beta like this, plus or minus cos alpha sine beta. Okay, let's do this a bit. Okay, so then here we know also that the identity of cos alpha plus or minus beta here, this is the same as cos alpha cos beta minus m plus them sine alpha sine beta like this here. So now we're going to substitute the identities that we have here into this expression here. So meaning that for sine alpha plus beta here, so we're going to have sine alpha cos beta plus cos alpha sine beta here, multiplied by the identity for this, simply sine alpha cos beta here minus cos alpha sine beta like this here. Then we divide everything by what we have below there. Okay, so now the identity for this here is, let's open the brackets this side, simply cos alpha cos beta plus sine alpha sine beta like this here. Then this side here we have a cos alpha cos beta like this. So this here is going to be minus here, so this is plus there. Okay, so minus this side. Okay, let me just switch the signs there. Okay, so now here we have a negative there, then this side we have a positive like this here. So sine alpha sine beta like this. Okay, sorry for the mix up there. So now here we multiply these brackets here, or expand the brackets that we have here, both on the numerator there and on the denominator there. So if you multiply sine alpha cos beta by sine alpha cos beta here, we're simply going to get sine squared alpha cos beta, cos alpha, sin beta, like this here. If you multiply cos alpha sin beta by sin alpha cos beta here, we're simply going to have plus sin alpha cos beta cos alpha sin beta, like this here. Then if we multiply what we have here, cos alpha sin beta by cos alpha sin beta here, we get minus cos squared alpha here and sin squared beta, like this here. Then we divide everything that we have there. Okay, something like that. Then we divide everything that we have with the expansion of what we have below here. So cos alpha cos beta multiplied by cos alpha cos beta here, simply going to get cos squared alpha cos squared beta, like this. Plus, if you multiply this with what we have this side, simply going to get cos alpha cos beta sin alpha sin beta, like this. If we multiply negative sin alpha sin beta by cos alpha cos beta here, we simply get negative cos alpha cos beta sin alpha sin beta, like this here. If we multiply negative sin alpha sin beta by positive sin alpha sin beta this side, we get negative sin squared alpha and sin squared beta, like this. Now, here, you notice that this term here and this term, they're going to cancel. They are same, but the signs are different here. So this term and that term are going to cancel, meaning that we are left with sin squared alpha cos squared beta here minus cos squared alpha sin squared beta here divided by cos squared alpha cos squared beta minus sin squared alpha and sin squared beta, like this. Now, here, to get the desired result here, what we're simply going to do here is we divide throughout by cos squared alpha and cos squared beta there. So I say dividing throughout here. So if you divide throughout by cos squared alpha cos squared beta here with every term that we have in this expression here, so meaning that here we're simply going to have sin squared alpha cos squared beta here divided by cos squared alpha and cos squared beta, like this, minus we divide also this term here by the same thing. So we have cos squared alpha sin squared beta, like this, divided by cos squared alpha and cos squared beta, like this. We do the same on the terms that we have on the denominator there. Let's scroll down a bit. So here we have cos squared alpha cos squared beta here divided by cos squared alpha cos squared beta, like this, minus sin squared alpha sin squared beta here divide with cos squared alpha and cos squared beta, like this. So here, when you simplify what we have here, let me just write it this way. When you simplify what we have here, you notice say that cos squared beta cos squared beta, they will cancel. Then we're simply left with sine squared alpha divided by cos squared alpha, like this, minus on this here. You notice that cos squared alpha and cos squared alpha here, these are going to cancel there. Then you're left with sine squared beta here divided by sine squared beta, like this. We divide everything here by this here, everything is simply going to cancel out. Then we're going to have 1 here minus here we have sine squared alpha divided by cos squared alpha here. Then we multiply with sine squared beta here divided by sine squared or cos squared beta, like this here. So we know that when you divide a sine function with a cosine function, we get a tangent function. So meaning that here we're simply going to have tan squared alpha minus, if you divide this to here, you get tan squared beta, like this here. Divided by down here, we have 1 minus, if you divide this to here, you get tan squared alpha. You divide this to here, you get tan squared beta, like this here. So if you look at what we have here, it is equal to our right hand side, this side on top here. Okay, so now if that's the case there, you can just say hence proved.